Okay, so let's take a look at, let's say we have a 40% solution, and we're going to take it through, we're going to dilute it 1 in 8. Find the new concentration. Find the new percent. What do I do? Perfect. Just 40% times 1/8, which gives us, of course, we just put this over 1. 40 times 1 is 40. 1 times 8 is 8. 40 divided by 8 is 5%. If we have 24% solution and need 4% solution, what dilution do we use? So how do we find that out? Perfect. So the new percent is 4% over the 24. Good. And then cross out the percents and reduce by 4. So it's a 1 in 6 dilution. Well, let's say that we have 240 milliliters of 60% solution. That we need to dilute to 20%. How much of neutral solution or how much sterile water do we need to add? Where are we going to start? Our first step, we're going to find the dilution. How do we find the dilution? New percent over old percent. 20% over 60%, which is going to reduce to a 1 in 3 dilution. Now, the 1 in 3 dilution, remember, is concentrate over total. So in this case, this is the 60% to the 20%. Neither one of those numbers represents what we're looking for, which is the amount of sterile water or neutral solution added to this. If it is a 1 to 3 ratio of concentrate to total, what is our ratio of concentrate to our neutral solution or sterile water? 1 to 2. Good. If 1 out of the 3 parts is the 60%, the other 2 out of those 3 parts has to be the sterile water. And we have 240 milliliters of that concentrate. We're going to cross multiply. 2 times 240 divided by 1 is 480 milliliters of that sterile water need to be added to that concentration. So here's another question. How much of a 72% solution and how much neutral solution need to be combined to make 300 milliliters of 12% solution. Where do we start? Well, we generally start with finding the dilution. What's the dilution going to be here? 12% over 72, which will reduce to 1 and 6. So now remember, the 1 is the concentrate. In this case, that's the 72%. And the 6 is the total, the final, which in this case is the 12%. Do we know either of those numbers? The 70, yeah, 300 milliliters of the 12%. Do we want to know the amount of the 72%? Yeah, that's one of the things we need to know. So we'll use that ratio right there. 1 times 300 divided by 6 equals 50 milliliters. That is of the 72%. Now I could just subtract here 300 minus 50 if I wanted to. But I'm going to go ahead and I'm going to create the ratio of neutral solution to our total, or our 12%. Which is going to be, well, the total is still 6 parts. If 1 out of the 6 parts is the 72% concentrate, the other 5 out of the 6 parts is our saline. We still have 300 milliliters total. Cross multiply and divide. We are going to get 250 milliliters of our neutral solution, saline. And of course, those two numbers do add up to 300, which means we're good. Or at least we hope we're good. So I want to know how much of the 36% solution to mix with how much neutral solution to create 480 milliliters of 8% solution. I'm going to give you a few minutes to give that one a shot. So we start with the dilution, which is always the new percent over the old percent. So 8% over 36%, which reduces to a 2 and 9 dilution. So once we have a 2 and 9 dilution, and of course that is the concentrate, which is the 36%, over the total, which is going to be the 8%. We know we want to create 400 milliliters or 480 milliliters of the 8%. Cross multiply and divide. 2 times 480 divided by 9. It's going to give us an ugly one. 106.67 milliliters of the 36% solution. Now again, we can either do 480 minus that to get the amount of saline, or what would be our ratio of saline to total? 7 to 9. Very good. And we still have 480 milliliters of total. Cross multiply and divide, which is going to give us 373.33 milliliters of saline. One last one for you to try on your own, then move on to something a little bit different. I want to know how much neutral solution to add to 180 milliliters of 80% solution to dilute 24%. Again, I'll give you a little bit of a few minutes to try that. So again, we start off by finding the required dilution, which is going to be the new percent of 24 over the old percent of 80, which is going to reduce to what? 3 to 10. There we go. Both of those can divide by 8. So we have a 3 and 10 dilution. Now remember, this is the 3 is the concentrate again, which is the 80%. And the 10 is the total, which is going to be, of course, the 24% in this case. We know 100 or 180 milliliters of the 80% of the concentrate. So we'll put that in. 180 milliliters goes with the 3 in this case. Go cross, multiply, and divide. 10 times 180 divided by 3 is 600 milliliters. Is that the number we're looking for? No, that's the total volume of the 24% when we're done. What we need to do is we need to take that 600 milliliters and subtract 180. Get 420 milliliters. The difference in the volume must be made up by that neutral solution. Let's see. Or we could have adjusted. We have the dilution of 3 to 10. We could have done, if it's a 3 to 10 ratio of concentrate to total, the ratio of concentrate to saline would have been 3 to 7, and we could have done the ratio that way, the proportion that way. Okay, so now that we've kind of beat this to death using the dilutions, there is another way to adjust the solution concentration. We said before that we could use a dilution, like a 1 in 8 dilution, would be equal to the new concentration, the new percent, over the old percent. These are volumes here. The 1 would be the volume of the concentrated, of the old concentration, of the old percent. The 8 is the volume of the new concentration. Now you can see that's flipped over here. The volume of the new concentration is on bottom, while the actual percentage for the new concentration is on top. But if we look at this formula and we rearrange it a little bit using some algebra, and what I'm going to do is I'm going to put some symbols in there. The volume of the old concentration is going to be V1. The volume of the new concentration is going to be V2, volume 2. The new concentration then, that's volume 2, so it's going to be concentration 2, or C2. The old one, then will be the original, or C1. If I solve this equation, rearrange it a little bit, doing the cross products, I get V1 times C1. Going the other way, I get V2 times C2. So from that dilution formula, I get this formula here, which is the concentration adjustment formula. Or sometimes called a change in concentration formula. So what it allows us to do, like what we were doing with those dilutions up above, let's say we have 300 milliliters of a 48% solution. We want Oh, let's say we want a 12% solution. How much of the 12% will we end up with, will we have when we're done? So 300 milliliters, we're going to let that be V1. That's the volume of solution 1. Now, its percentage, its concentration has to be C1. What is the concentration of the 300 milliliter solution? 48%. So that'll be C1. So we have 300 milliliters times 48%. Notice I left the units off. The 48% is just 48. I could use 0.48 if I wanted to, but I don't have to. To me, it's simpler just to leave it as 48. And that's going to equal... Now, on the other side, I'm going to have volume 2 times concentration 2. Do I know either one of those numbers? We know the concentration is going to be 12%. The volume we don't know, that's what we're going to look at. That's what we're looking for, is how much of that solution are we going to have? So we have this formula right here that we need to solve for V2. So we're going to take 300 times 48, which is going to be 14,400, correct? Okay, equals V2 times 12, and what are we going to do with that? We're going to divide by 12. It gives us 1,200, and of course that'll be milliliters. How do I know that's milliliters? Yeah, the volume, the other volume was given in milliliters, so the new volume has to also be in milliliters. So 1,200 milliliters of that 12% solution will be created from that. So let's say that we have 32% solution. And we need to create 360 milliliters of 4% solution. You guys have a great week. How much of the 32% solution do we use? So we're going to start out the same formula. I'm going to write out the formula and then we'll plug in numbers as we go. So volume 1 times concentration 1 equals volume 2 times concentration 2. Do we know volume 1? Well, that's actually what we're looking for. We better know concentration 1 then. That's the 32%. Equals volume 2, 360 milliliters, and concentration 2, 4%. Now you might be wondering, why did I make the 32% concentration 1? Why couldn't I have done the 4% as concentration 1? I could have. It doesn't matter. It makes no difference which one we choose to be which, just as long as you get the volume with its correct concentration. So, what are we going to do from here? Well, 360 times 4, 1,440 equals V1 times 32. From there, divide by 32, V1 equals 45. Very good. And that is milliliters. So we only need 45 milliliters of that 32% solution. We're going to step this up a notch. So let's say we have 54% solution. We need 720 milliliters of 18% solution. I want to know how much 54% and how much then a neutral solution do we mix together? So our adjustment formula here still helps. Still going to make things a lot easier for you. But there's going to be a little extra work when we're done. So what do we put in here? Do we know V1? Well, first of all, which percent do we want to let be C1? Let's just pick that first. You guys choose. It doesn't matter to me. 54 or 18? 54. So 54 goes in for C1. Do we know V1? No. We're looking for how much of the 54. So on the other side, C2 then, of course, has to be the 18. We better know V2, the 720 milliliters. Now what? Well, we're going to do the 720 times 18. Then we'll divide by 54. Which is going to give us V1, better be 240 milliliters. V1, of course, is describing the 54% solution. So that's 240 milliliters of the 54% solution. Is that all we need to do for this one? How much 54% and how much saline or neutral solution? How do we find the amount of saline here? Well, we have 720 milliliters of 18% and 240 milliliters of 54%. The difference in that volume must be made up with saline or some sort of a neutral substance. So we're going to do 720 minus 240, 480 milliliters of neutral solution. I'm going to have you guys try one of these. So we have 35% solution on hand. We need 260 milliliters of 15% solution. So how much 35% and how much saline do we mix together? I'll pause. So let's take a peek. Which percent do we want to choose to be C1? 35 or 15? Somebody yell one out. 35. That works for me. Do we know V1? Say no. Good. On the other side, C2 then, of course, has to be the 15%. Do we know V2? 360. Good. So now what? Okay, 360 times 15 is going to be, what, 5,400? And then we'll divide by 35. Oops. So V1 equals 154.2857142857, something like that. We're just going to round it off to 0.29 milliliters. And then, of course, we still need to know how much of our saline. So we have the 360 total minus 154.29 milliliters is going to give us 205.71 milliliters of sterile water. Of course, this was of the 35%. What do we think of this stuff? Well, since my voice is rapidly going, and you guys, some of you guys sound almost as miserable as I do, I think we've had enough for 1 week. So on page 130 to 132, 1 through 37, the odds, talks about the basics of dilutions. Page 134, 1 through 11, the odds, talks about adjusting the concentration of a solution with the dilution and what dilution is required. And then page 138, 1 through 17, the odds, goes over this concentration adjustment formula.